Buonasera. I'm Pau Sarsanedas, the CEO of GPA INNOVA. And we are here again for a second time, exhibiting here in EMO with our Delight machinery for the surface treatment using the dry electropolishing, the first dry electropolishing system for metal surface finishing. We are very happy to be here, and I hope you like my presentation. GPA INNOVA is a technological platform launched and born in 2013 with the aim to develop technological products for a very huge impact in the different fields. And mainly we are focused in the surface finishing treatment, thanks to our new technology, the dry light, applied specifically for markets like dental, healthcare, and industry in general. Additionally, we have another products, thanks to our synergies with our huge team and specific knowledge with different skills. We are able to develop products with with very different applications, thanks to our engineering of electronics, software, mechanicals. And this is why GPA INNOVA today is one of the most growing companies in Spain and also in Europe. We are very happy because we grew a lot. We are one of the most growing companies in Europe. We are multiplying by 3 the turnover every year. And we hope that we can be one of the leaders in the market very soon. Today, we are reaching this year 25 million turnover, and this is a very huge rate of growing if you are more understanding how is the growing level of goods. Delight is our key product. Delight is the brand of our machinery using our dry light technology, and today is the global leader in metal surface finishing. Why? Because we are using a very specific technology able to remove roughness from metallic parts, keeping the geometry and not rounding edges. And this is one of the most interesting things of our technology. It becomes today one of the main products of our catalog. And we are here showing all of our range of machinery ready for industry. Basically, this technology, it works with a plastic media, is resins. These media are able to attach, to cap our chemicals inside, because we are using a very hygroscope material. And our chemicals are implemented inside of these particles. And applying high-frequency currents between the parts and the cathode that we are applying in our tanks, we are able to move parts inside of this media, and that media removes only the peaks of the roughness. This is very interesting because normally the electropolishing systems are removing also material from inside valleys. Inside valleys is not desired because otherwise you are not able to remove roughness completely. And here, thanks to this concept, easy concept, to use solid media to remove by ion exchange system, we are able to remove roughness. And again, the most important thing is that we are able to keep the edges, and we are able to reach corners and very difficulties and very complex geometries. This is one of the key advantages of this technology, and this is why we are getting a very huge success in a run of different fields, and mainly in medical, because it's very important to keep geometry and with a very low level of roughness. And a short explanation about the difference between the wet electropolishing and our dry light technology is that, again, if you see the picture, the wet technology are removing material also from the valleys because the liquid are in contact in all of the surface. And this is why, finally, the aspect and the final quality of the metallical parts polished with wet technology are really not flatness, totally flatness, as we are doing with the dry light media. In the right side, you can see one picture of a knee implant during the process. And it's easy to understand how it works because the particle is around 0.8 millimeters, around like that. And moving parts inside of this media, we are able to remove completely the roughness and achieving level of roughness around 0.09 microns array is very, very low. And this is why we are implementing our machinery in a lot of different companies. I think one of the key things about our success is the many advantage of dry light. One of the key advantage is that we are removing dust also from the surface. We are polishing, but at the same time, we are removing all the contamination. These materials are very hygroscope, and at the same time that we are polishing, we are cleaning the surface. We are increasing a lot the oxide resistance, because at the same time that we are polishing, we are passivating the surface. We are oxidating the surface, and we change polarity with a very high frequency ports, and we are able at the same time to passivate the parts. This is very interesting for many applications in pharmacy, in medical device, that after polishing, normally they need to passivate the technology. For friction applications like bearings or guides, we are removing only the peaks, and this is why for lubrication and for friction systems, the SKF roughness are in a very good level, and this is why for bearings and applications like that is very interesting. After the process, normally with mechanical polishing, it keeps a pattern, because when we are using a mechanical or abrasive, after the process, keeps the pattern of the process. Very small scratches that can create fatigue cracks, and with our process are completely without any pattern. This is why the resistance after the process are really, really high. Additionally, we are preserving the tolerances of parts with a very high level. This is why we can use the dry electropolishing for a very high-end milling parts without losing the adjustments and tolerances. And it's a totally full automatic process. We can automate the process with our robot stations or with our software with completely control of parameters. And we can change the model of, I can say, manual polishing. That there are a lot of companies that still they are using manual polishing for finishing a lot of different parts. Here we are offering the first possibility to automate the process. Again, the level of roughness that we can achieve in only one step is incredible. We are achieving in sometimes less than 0.05 microns array. This is very, very low level. We have acceptations worldwide about the medical implants achieving half of the roughness desired. And very important, we are talking about a very 100% clean technology without any dusts, any powder on the air, any liquids after the process, and is considering dry light technology as a completely green technology. This is very important. It's completely 100% recyclable after the process. And this is why we have a very good acceptations also to improve the level of sustainability of the surface finishing treatments. The applications today of dry light with this very high growing level mainly are focused in watch manufacturing, healthcare, for polishing cobalt chrome and titanium. Titanium is one of our key markets. We are able to polish titanium with a very high level of quality. And this is why in medical field we are very implemented. Also, in automotive market, we are polishing gears, camshafts directly with one step with a very fast and easy system. And in this EMO exhibition, we are very happy to show finally, after 4 years of innovation, the first system for polishing carbides, carbide tools. This is a very important market because there are a lot of requests for removing roughness without effect edges. And this is why today we are very happy to show the first results for this huge market. But again, the applications of dry light, you can see here, is very, very extensive. Tool industry, gears, cobble chrome, stents in medical, aeronautic parts. It's very, very flexible and very profitable technology for a lot of different cases. Our range of machinery are coming today from a very small machine, the desktop machine, top table machine, able for all type of companies, until the Delight 10,000, a very big machine for polishing big parts. Today we are very happy to present the Pro 500. It's the first massive polishing machine automated by our first automated cell, ready for loading and unloading holders directly with a robot and applying the parameters from outside of the cell. This is very interesting for automatize all the process of polishing, and we are very happy to show here in our booth, just behind of the speaker corner, and showing you how it works, because we are very, very happy to be ready for a demonstration. Again, I want to explain you what we are presenting here. I think is a revolution. We have finally the first technology able to polishing carbides without leaching effect. We are removing the cobalt at the same time of the carbon. It means that we are able to polishing tools without preserving the edges, rounding a little bit the edges at the certain level of the requirements of tools, around 8 microns, 12 microns. And I think is one of the big revolutions of polishing today. I think very soon we will have a lot of customers in that field. We are very happy to attend you in our booth here. Every year is bigger and bigger. Today we have a very big booth and we can show you all of our range of machinery. And that's all. Thank you very much. And I will be happy to share with you a very short video about our company, how it grows until now, and what is the real potential of GPA INNOVA from now and for the future. Thank you very much.